the floor is Milind. Milind, welcome again, and thank you very much for your time.
Awesome. Thanks a lot, and thanks for having me in your esteemed speaker list, Prashant. Happy to share my thoughts. I'll share my screen and then get started.
Sure.
So let me know once you start seeing the nice sports car, please.
Yeah.
Yes.
Yes.
Okay, cool. So let's just breaking the ice before we get started. So this is AMG, Merck AMG, and there's racing in US called like not NASCAR, but this is like the tier 3 league, and this is called EMSA, and there is a big data car, and we along with Cloudera, Modak, Telic, StreamSets, and other guys, we sponsored this race car for last 3 years. This year, the season is not there because of the COVID. The idea there is, can we use analytics to enhance the performance during the racing? So we collect like real-time statistics, build some dashboards, and then help like where the driver had problems. And you wouldn't know how much data they have even in racing. It's just amazing. Getting started. So again, just let me introduce briefly. And again, thanks for that kind introduction, Prashant. So at heart, I'm a techie. I did my computer science. I joined IBM as an intern, stayed there for 15 years in US, and led a lot of leadership positions, mostly in data. I was fortunate enough when this whole practice was called business intelligence back in 1997. Worked with a lot of major financial services companies in US as well as in Latin America, India. I was the customer and marketing analytics head in my last role at IBM. And after that, I started my journey in Modak. And what we do at Modak is we started out more as a data aggregator for India. And then that's where you hear that election stories and all those things. And then we slowly pivoted into what our core was, which is services, intellectual capital. And then I have done for last 23 years, I have only done data integration and data engineering, and walked through probably a lot of buzzwords like business intelligence. It was called analytics. It was called advanced analytics. Then it came to be known as big data. But we are primarily solving similar problems, but right now at a larger scale, right? So this is my brief agenda. And what I'll do is I will try to finish that off and leave like 10 minutes for questions at the end, and then go there. So my agenda first would be, and probably most of you who are in this call already know this, but I want to lay my spin on the problems we see in the industry. What are the data engineering problems? Why are those that big a deal? And how to get over that hump. And the next aspect which we do, and our primary purpose is how can we accelerate the journey for our customers and bring faster time to value. And that's our key strategy, is how do we accelerate? How do we get out of the rut and accelerate all the things we do? And then I'll give some examples of how we have done some real world accelerations as far as building of data platforms is concerned at some of the, I would say, top 10 pharma and life sciences companies. And then leave some details for questionnaire. I'll not spend a huge time, but just give you a perspective of where we come from. So we have about 260 full-time employees at Modak, spread across US, India, and Middle East. We are primarily a service company, but the good news is we have a lot of IP. So we have a product called Nabu, we have Fireshots, we have Almarin, we have like a huge repository of open source contributions made by Modak. So we really think of ourselves as a very intellectual property driven organization. And we use these accelerates to accelerate the data engineering journey by 4 to 10x. And that's what we do. Personally, like I said, I'm technical. I, along with my partners, have about 6 patents in this field. Very deep technology company. That's how we love to do. And the only thing we do right now is data engineering. We hardly even do anything with machine learning or predictive analytics or any of those things. We are very, very focused on the data engineering aspect of the business. Now, let's get started with a brief personas of the people who are in this space, right? And what are their struggles? So if you think about the personas right now, one of the challenges, if you're a data scientist or you have come across one, is the frustration he has getting access to the data. And I'm talking about enterprises. I'm not talking about the competitions, or I'm not talking about very small companies. I'm talking about Fortune 100 or Fortune 500 companies who have some huge issues in terms of being data-driven organizations, right? And then if you look at like what a data engineer does, one of the big challenges for anybody who has done data engineering or data integration in the industry is, apart from the fact that they have to code it, the changes that are always coming for the same piece of pipeline and the modifications they need to do. It's insane because of the data quality issues, or business has changed some business rule, or if you're done any kind of production of a pipeline, the iterations that are happening are mind-boggling. And then if you talk to, let's say, a CDO, right now, his thing is, how do I make more citizen data scientists? How do I make sure that the data is exposed to pretty much everyone in the organization, and they leverage that data to make their decisions? And then IT always has these issues, like how do I support scalability? How do I manage the flood of requests which they come in terms of data requests or platform requests or stuff like that. So these are the different personas we deal with in our organization. Now, what are their challenges? These are the personas, but let's look at like broader challenges as they relate to our domain. So if you look at like the conceptual data landscape of an organization, you have silos. Everybody agrees that silos, but those silos, if you compare an enterprise, are much broader. What do we mean by that? So you have multitude of applications, and each application in their operational system has its own data store. And the funny part about this is data moves between one operational store to another operational store, maybe gets a little bit modified, or the same data is there. Imagine how many customer repositories would these guys have. There will be a customer repository with sales and marketing. There will be one with the finance, where they have the customer information. Then there will be one with your operations system. So just the customer information itself is spread out, and they have various degrees of what they have. And then from each operational system, like I earlier alluded to, the information flows, and you really don't know where that information is, what they're doing. And a couple of organizations we deal with have like about 2,200 different data stores, or I have seen organizations where we have 3,000 different data stores. And we are talking like crazy number of data stores, right? So this is the conceptual landscape if you look at one data. But that's not true. This is the more realistic, what you call landscape of how enterprises have their data. So you have your operational data, but that's just 20% of the data, because the other 80% of the data is unstructured data. It is in PDF files, it is in Excels, it is in what you call Word format documents, you name it. It's in images because we deal with life sciences companies, or also because we deal with life sciences companies and financial companies, a lot of the data is in SaaS data sets, right? Now that is the operational side of the data. Now, if you come to the informational stack, you have enterprises have created data warehouses, they have created data marts, they are doing some reporting, they have access to external data stores. So it becomes and this is, we're just talking about a single department. Imagine that like siloed across the organization. And this is, we see this very, very, very often, right? So nobody has this enterprise data warehouse. Nobody has this, even if they create data lakes, now they have multiple data lakes. So it's really funny. And now with the cloud, you wouldn't know, like every company has access to at least two clouds. So either they have data now in AWS, or they have data in Google, or Google and Azure. So everybody has two cloud providers. And the other funny part is with the SaaS services like Salesforce, CRM systems online, and your ServiceNow processes being online, now your data is also online. So you have to bring some of that data back into whatever ecosystem to process that, right? So you have all these partnerships. Now in all these situations, how do you generate insights? Because that's the whole premise of why I'm here, or why business is interested in creating a data-driven organization, or all those things. Now, going back, let's understand that process and how industry deals with it, right? And when I say industry, I mean more of enterprises. You have siloed data on the left-hand side. You have the business people on the right-hand side. What they do is generally, typically, a business comes up with some hypothesis or a group of hypotheses, or they don't even know what they want. So they just have a broad idea of where they want to go. And that's what the initial definition of the business use case would be. So they say, okay, I want to generate insight. And then what we do is we go back and say, okay, I need to understand what data I have to whether I can support making those decisions. Then most often than not, those data is not in a curated form. So you go and or you don't know what you want. So you go and see whether there is another set of data. So you go back and discover new data. And then you go back to your operational systems and say, can I have some data to support this use case? And that's what happens between the business, the data scientist, and then the operational world of data silos. Again, they find the new data, they understand the data, and then again, they generate the insights in few cases, and this loop goes and on the way enterprises want, right? So this is the classic case of how it evolves. Now, to do all this is great, right? This is, I explained you the process of how enterprise goes about generating insight for the data. Now, what are the problems? Why are they not achieving as much success as they love to, right? And this is a chart I picked up from Google. I love this chart because it succinctly tells about the problems we are dealing with in enterprises. This is the data challenge quadrant. And what this chart is telling is 50% of your work you're spending on data discovery. And as a practitioner for 23 years primarily on enterprises, what I can definitely tell is this is true, because people struggle to find useful data. They spend way too much time trying to discover new data sets, or whether that data set has a proper quality, or this is the version of truth, or there is some modified data which is better. So they're spending a lot of time discovering data. Obviously, the reason we are here, or you're interested in this call, is 80% of what we do is data preparation. I would love to say that even the data discovery, I consider it part of data preparation. I will not even talk about the data quality, because everybody suffers. Anybody who has done any kind of data analysis knows the problems with data quality. The interesting part here is about dark data. What do we mean by dark data? I'm not kidding. When we have gone in enterprises, I think only 5% of the data is useful. 95% of the data is like either repetitive, or it's not even useful for your business. Finding that 5% is what is the goal of the data. That's what they are terming here as dark data. But what I term as dark data is a bit different. What I term as dark data is the fact that almost, I have seen in some enterprises, 50% of the data is stale data. It has not been updated for years together. People don't even know. They're just supporting. I have seen DBA teams support 600 data stores where the data has not been updated for past 2 years. It's just lying there, and they're just supporting, opening up tickets and doing all these things, right? So this is the data challenge quadrant. So these are the problems we deal with in enterprise. Now, similar spin, but I still want to show you the chart. This is from Gartner, and they have laid out the challenges which you have for preparing and governance. And they have done a survey, and they have asked enterprises, what are their biggest challenges? Again, 58% of them say identifying data is my biggest challenge. Then comes the governance. I'll talk a bit about that more. But if you look at, only 26% of them have a challenge of processing large volume of data. And given the fact that we are in this like explosive phase of growth of cloud, and that is not surprising, right? They are saying, I don't even care about processing large volumes of data now, because I can tab into different clouds and get that done. people are not even there in enterprises in terms of IoT, while we think that's like the latest hype, but and edge computing and all those things, only 12% of them are really worried about it. What they're worried is more fundamental. They're worried about how do I prepare my data? How do I support my new use cases? How do I govern my data, and how do I identify the data? And what do I mean by data governance? And this is one of the important pillars of how we are discussing it. So imagine any organization, and we are talking about enterprises. They have certain challenges in terms of who gets access to the data. So they have some sensitive data, so they don't want to expose it. So the data governance teams have data stewards, and they figure out like they need to de-identify PII data or GDPR data. They want to have metadata associated with that data, so they want to tag each and every field. Then they have their own preconceived notions of single version of truth. I have never seen any enterprise come and say, this is my single version of truth, but that's the holy grail of data governance, right? So they want to support various different single versions of truth. And that's another struggle which enterprises go through. Now, another problem. So how do we solve this problem? The reason we are here is we are saying that data preparation is there. I'm putting some scary numbers out there that 92% of the analytic projects in large enterprises are stuck in neutral. And I want to qualify that statement. What I'm not saying is that 92% of them are failing or 60% of them failing. What I want to tell you is enterprises invest humongous sums, both in terms of people, processes, as well as systems. And they have invested that, they have made all these investments. And the funny part is they have either done 1 or 2 use cases and then it gets stalled, because to do 3rd or 4th or 10th or 50 use cases on a data lake or the platform they have invested takes humongous ramp up and more resources to do it. So what happens is that whole platform, which they envision will support like 100 use cases, now is stuck supporting like 2 or 3 use cases or 4 use cases. In fact, multiple teams have built multiple platforms, and all of them are, still see that they are not supporting the amount of use cases you want them to support. And that hinders that. That's why I'm saying that 92% of them are stuck in neutral. And then this is the latest hype, right? And I, as a person, having done my own predictive analytics, machine learning, and all those things about 5 years back, I realized that the problem is not that. While we are, as an industry, we are always hyped up about the fact that BioBERT has come and this is, or the BERT algorithm, BERT has come, or next version of NLP, or this XGBoost, or SVM, or is GBM better than SVM, or whatever that is. We are so concerned about that 20%, which is machine learning and predictive analytics. We fail to understand that to get to that data, it takes me a lot of time, for enterprises at least. And now with AutoML coming up, I don't even know whether you are required, honestly. Means as far as I am seeing, 95% of the work we do is data preparation and getting that data ready to be fed into whatever you want it to be fed into. So how do we solve this? How do we ensure that enterprises don't take 80% of the time building for their business use cases? This is where about 5-6 years back, when we were developing India-based repository for ourselves, what we realized is we had a small team, we had a 14-member team. What we realized is that how do I automate a lot of these processes? And we are talking about, when we were building it for India, we were talking about 150 different data sources, changing with different kind of schema drifts and the layout changing and all those things. Plus the fact that we are talking about a billion population and creating attributes for a billion population. So humongous scales in terms of diversity, and we only had 14-member team back in 2015. So we strived very hard to build automation and apply machine learning in the data preparation itself. And how do you reduce that time it takes for me to put that data back into the model so that I can get the results very, very quickly. So we don't focus on the insights part, we focus on the data preparation part. And what we are doing is we are applying automation and machine learning to automate the repetitive tasks which happen during the data preparation. And what do I mean by that? So we have data spiders, and the data spiders grow and crawl all the metadata which is available in different enterprise repositories, be it structured or unstructured, right? Then what else do you do? We automate the whole pipeline generation. We don't care what tool it is, but the idea there is you need to automate how you bring data to a single platform, or even if you don't bring that platform, to glean the insights right there at the source. So you have to have some processing capability, but most often than not, you can't really glean insights on the operational system. So you make a copy of the data. So you need data pipelines automatically built for you, which like transport that data into wherever you are doing it. After that, you profile that data, because a lot of the times you don't know what kind of data it is, data quality or whatever. To understand the data, you need to profile it. And we have another proprietary, this is where the machine learning comes. We then fingerprint the data. So what do I mean by fingerprint? Assume you have social security number in US, or a zip code or an address or a name or whatever that is. How do I learn that this is always the social security number, or this is always the address? This column means first name, this column means last name, or this is customer ID, or this is product ID. And once I learn them, even if the column is named something else, I automatically learn that this is what the column is, and then propagate that meta and tag that data. And that is immensely helpful for data scientists, right? So both the tagging and fingerprinting happen. What does this do for me? What this does for me is, if I have, you can ask any data scientist this, if you have access to the data is profiled, it gives you a score of quality, plus it is automatically tagged. By that, I don't mean that if you have a file with, like, let's say 30 columns, all 30 columns need to be tagged. What I mean is the major columns are tagged, like this is customer ID. So you can know that this data is about customer, or this is about a product ID. So you know that this data is about product, or this is social security number. You know that there is a social security number associated with data. So you can start making some inferences. So that's what we mean by tagging. So you tag the data, and then what that does is it significantly reduces the time. Now you're solely focused on the business problem, not on this whole grunt work of doing all these things. So that's what we mean by reducing the time. And industry has coined a term for that, according to me, and that is called augmented data preparation. And this was primarily called by Gartner. And guess what? This is 2020 trends which Gartner lists, which is, you have number 1 trend is augmented analytics. Number 2 trend is augmented data management. Number 6 trend is data fabric. So the industry is slowly realizing that the volume of data you have, without all these enabled and without the automation enabled, there is no way you can be successful at the scale we are talking about. And I'll give you some examples later about the scale I am talking about, right? Now, these are the predictions again with Gartner. So what does Gartner think? So Gartner thinks that by 2024, augmented data management, or you have these, what I call data catalogs or data virtualization tools or data quality tools, all will converge into something called, they are calling it consolidated data fabric. But there are multitudes of tools available right now which you need to integrate to get this capability. But what Gartner predicts is all those tools will come and start forming into a coalition of tools where they start sharing metadata and making that magic happen. Because right now I have to buy a data quality tool, I have to buy a data unification tool, I have to buy a data preparation tool, I have to have a catalog, and I know the mess it makes for us if you actually want to implement it. Let me get to the next slide. Now that we spoke about it, let me drill down the problem further and what I mean by that. What do I mean? What is augmented data preparation? Why does this take time? Or help you understand where I am getting by some examples. And let's say an enterprise is coming up with some use case, a business use case, right? If you look at typical timelines, I'm talking, this might not be representative of all enterprises. This might not be representative of like small projects which happen in enterprises. I'm taking a typical use case. If a company gets started on that, it's like a 6 months time period. I've seen anywhere from 3 to 6 months. And most often then they take like a year or 2 years, depending on the complexity of what they're trying to solve. But These are the timelines I laid out just to have there. So the first thing is data ingestion. So in these things, there are certain processes you need to do, right? You need to discover the data, then you need to map the data. What do we mean by the mapping the data? That, hey, I got the data from the database. It is called cust ID or ID, but nobody knows what that means. So you need to like map the data and say, this is customer ID, this is like date of birth, this is gender, whatever that is. Then you need to start ingesting the data, and then you need to create a lineage of the data. Where did this data come from? And then you need to build a pipeline, and then you need to ensure the refresh frequency and all those things. And once you are done with that process, you go to the next set of the processes. You run profiling on the data. And I'm assuming most of you, since you're on a thing about data engineering, you understand what I mean by data profiles. Then you do some data quality work. You figure out, like, I've seen so many times that data which comes from operational systems, every time you have to go back and talk to the customer, because customer thinks there are only 4 codes or 5 codes. And then when you actually see the data, there are like about 20 different codes. And then you need to sit with a SME or a business SME or a data SME and understand what each one of those codes means in terms of data. Of course, there are issues with missing data. There are like duplicate data. Then the next set of problems is, if you go in the enterprise, it's not so simple that you can go and collect the data from production system and start using in your development work. No, that doesn't happen. Life is not so easy in enterprises. There are privacy concerns on the data. So you have to de-identify the data, anonymize the data before you can use it for your development or testing activities. Of course, there are security restrictions, access. And then another thing is, if you have huge volumes of data, then you have to manage the change data capture, which is like, I want delta data, and then I want to ensure on my other side, I have a proper set of data. Again, you have to take care of schema drifts and other things. Then when we get past that stage, then the business SMEs, data SMEs sit down and start tagging the data. Then they start defining the target models. Then they start defining how this data needs to be merged or joined. Then they need to explore the data to figure out whether that's what they need or is there anything else. There are other activities there, like some people want like MDM, single version of truth. Some people implement quality rules in the pipelines. Then they build data features, then do some kind of feature engineering for the data scientist, or they do transformation rules based on what the business wants and what the target data model is. So this is iterative work, right? And this takes lots and lots of time. The final layer, what I call the insight layer, is how do you use those features for AI and ML? Are you building dashboards, KPIs, microservices, whatever that is? That's the thing. And all this has to be orchestrated in DataOps, right? So you need to understand, how do you provision it? How do you test it? How is the production, development, deployment, monitoring, and then CI/CD processes. So it's like humongous. That's the reason why they take so long. Now, what is the solution for this, correct? So what we have seen, and this is like, I'm not saying that this is marketing hype or anything. We have actually achieved this acceleration, and I'll give you some examples how this enabled that, right? So imagine data ingestion. This process needs to be automated. If enterprises are going to strive in this digital age, they have to automate data ingestion, data profiling, quality, tagging at some level. They have to do this. So what we are saying is, if you automate until the fact that you're doing data tagging, because you have to make the computers or the machines also learn. So you have to apply ML there and say, you have to teach the computer that this means customer ID, this means product ID, this means this means gender, this means email. So you have to teach them those kind of things. And then once you start teaching them, for every use case you do, I have already learned a lot of things. I also have learned what kind of transformations you have done on the data. So this is like, it goes back and feeds my metadata repository. So what I'm saying is 60% of that can be automated, 40% of it will be like manual effort with specific to business. And then 90% of your profiling will be automated. Some ingestion can be completely automated upon me. And then on the consumption side, because of different use cases, obviously that has to be augmented, or you need to help it, but it's not truly automated. That can never be automated, correct? Now, with this, if you apply this, what we have seen is we have seen like 10x acceleration in how quickly you're able to deliver business use cases. And that's where I'm saying augmented and automated. Augmented is you're still seeking some help from the machine and you're doing manually. Automated means it's completely automated, driven by processes, and things are happening without doing this. Now, this is what I call 8 steps to data engineering journey, right? How do you accelerate it? So if you look at what I'm talking about, the 80% data preparation. So in that, what I claim is that 70% can be automated, and 30% is where your time you need to really spend is on business transformation rules or data transformation for the specific business use cases. And how do you get that? What you need is you need automated data discovery. So you need spiders in your environment which go and crawl all the metadata. You become catalog of catalogs. That itself enriches you knowing where that data exists. Second one is you need to build automated pipelines. We use bots to do it, but you just need to develop automated pipelines and ingest all that. Obviously, you need to have a metadata catalog, which feeds all this information. So it truly needs to become what we call active metadata. And I don't have time to get into that. That's a whole different topic. But the topic is active metadata. And what we mean by that is you need to have data from your technical metadata, you need to have your business metadata, you need to have your tribal metadata. What do we mean by tribal metadata? Imagine an enterprise, you have a couple of people building a use case and then they're moving off to another team. You have lost all your tribal knowledge. How do you capture that tribal knowledge back into the metadata repository? So you need to have that. Another part of that metadata is operational metadata. So you need to capture the operational metadata, where once you capture the operational metadata, you know what data moved when and who has access to it. So you need to do that. Of course, the next 4th step is data profiling. And I already went in there. You capture data lineage and a data tagging exercise, which is partially automated. And then data transformations for business specific use cases. I don't know. I love to automate it, but I have not yet seen anybody automate that to a level I would love. But obviously you can augment it. You have the previous knowledge of how certain data was transferred, transformed. And what you will do is you'll use that and apply there. So that's the acceleration journey. How are we doing on time, Prashant?
So we should be good. Yeah, so we are good. Yeah, so it's a 1 hour presentation. You have about another 20 minutes easily.
Sure. Okay, good. So I will spend last 10 minutes explaining some of the real world accelerations we have done at enterprise, and then you'll get a scale of things what I'm talking about. And those kind of transformations you can only do using some kind of automation. So this is a top 10 pharma. This has been spoken about a lot in there. And then this is about their whole R&D, right? In their R&D divisions, we developed like this data spider, we deployed BotWorks, and then I'll go into we also like manage their whole data ops operations. But I'll go to the nice visual chart of what we are talking about here. This effort was actually awarded in 2017, and this took like about 9 months to deploy the first version of what we are trying to accomplish there. And I'm not talking about business use case. I'm just talking about the whole infrastructure and what it is. And they won the Strata Award in 2017. In this case, we had almost about 2,200 different structured data sources. These could be your Oracle, SQL Server, Postgres, MySQL. We had about 6 different versions of databases, and there are 2,200 databases. We are talking about, look at the scale of operations. We're talking about 500 million tables, 500,000 tables, 500K tables in those 2,200 data sources. We had close to about 1,300 unstructured sources, which comprised about 1.3 billion files. So this was like your Documentum, SharePoint, Linux file shares, Windows file shares, and other things. To manage all this, we had to create an on-prem Hadoop cluster of 1,800 nodes, and it has now grown by another 600 nodes since that happened. And we're talking about 15 petabytes of information, right? This whole thing without automation couldn't have been stood up in that kind of time. Imagine manually building 500,000 data pipelines. Impossible. Imagine even trying to make sense of what data is there in that. And again, to my earlier point, out of the 2200 database, I think only about like 600 of them and a subset of table within them are useful. Everything else is duplicate information or information that's not truly useful. But across the enterprise, you at least need to understand what data assets you have. Now, that is all the technical story. What is the business story? So in last 3 years, we have done 65 different business use cases on this platform. I'm extremely proud of that because that's what the value is, right? You can talk about the technology or whatever you want to, that's not true. And the other fact I'm extremely proud about is as a analytic professional, first time I am contributing to a drug discovery process. So imagine building solutions for a life sciences company where this information, what we do for R&D, research and development organization of life sciences company will always be used for human betterment. And the fact that they will be used for drug discovery, new drugs. So extremely proud of that. So we were able to achieve this, and we had never worked on life sciences before. Now we are one of the few companies which understands life sciences domain data after 3 years of working there, but a great use case of how we delivered it. Now, I'll just briefly speak on what that architecture looked like also, right? So I talked about spiders and the bots and all those things. So this is the logical architecture. So you have all your sources, structured sources, unstructured sources. So what we used to do is we used to crawl all the technical metadata, store it in metadata catalog, which we call COSH. Then using that metadata, we would generate pipelines. And this could be generated, we have generated for our clients pipelines on stream sets, we have generated on Apache NiFi, we have generated on Talent, we have generated on Informatica. We can generate pipelines for any tool. So it's not like a black box. In fact, now we are generating Spark code where you can execute your pipelines. And the next step for the journey is, can we generate AWS Glue code without even you need to doing manual intervention there and generate that pipeline. And this is not as trivial as copying data from one place to another place. Anybody who has done enterprise kind of data ingestion knows that there are a lot of mappings, whether the target system supports it or timestamp conversion, date conversions, all those things. So we brought it into what we call foundational layer. And then from foundational layer, we go through this exercise of data profiling, then fingerprinting the data, tagging the data, doing some minimal cleansing, which we automated, capturing the data lineage. And then we have this ready to use data sets for data curators. And then they transform that data and put it in integrated layer. And then the clients consume either using visualization tools, or the data scientist will take those data and build their features and start using that. So that's the overall logical architecture of this whole process of what we build there. The next one which we did, and we are still continuing to do, is we built another data fabric for top 5 healthcare insurance company. So again, US, it's one of the largest healthcare insurance company of the world. And what they wanted to do was build an enterprise data fabric. And this is very, very interesting thing because the insurance companies are leading that healthcare revolutions where they're trying to ensure that their data is available in a real-time mode. So they are a batch process company doing daily batches or weekly batches, and they slowly want to move into the near real-time delivery of data. And this is what it looks like. And what is interesting here is we are tackling both their informational stack as well as operational data stack. So for the informational stack, again, they have on-prem Hadoop cluster, they have on-prem operational data stores. They are operating on 2 different clouds. They have other tools on clouds. And then how do we do all those things? We don't care what cloud they use. We don't care what on-prem system they use. We need to morph and automate all that. So we do the same thing, automated data discovery, help them with ingestion, preparation of the data, make that data searchable, and make it cataloged. So example, what I'm saying when I say searchable is, imagine a data scientist saying, he can ask like, where is demographic data? So he should get the answer. That's the easy, that's what you're looking at the table level. How about he going and asking, can I find out where all the data about this particular customer ID is there in my data landscape? That's the power of search we are looking at. That's what we mean by searching the data. And then you also have operational. So once you build these data stores, analytical data stores, how do you bring that back in operational and make this data consumable either by microservices, or publish this data to your external vendors, or get that data in external form, do some analytics, and then put them back in some kind of operational data store. So we are building a complete enterprise platform for them, and we are accelerating that. Last 1 year, multiple use cases delivered, platform is up and running, developing new products for them. So really proud of those kind of achievements. Another thing which I will speak about, this is just a story of 9 weeks. 9 weeks back, we started in COVID with one of the top 5 pharma companies of the world. And they selected us just for our automation capabilities. They took reference of other pharma companies, called them up, said, is this all marketing hype, or they actually deliver it? Again, with all the automations we have built, we have crawled in 8 weeks. 8 weeks, what was achieved? 8 weeks, the platform was up and running on AWS. We crawled 200 data sources. We ingested data of about 30,000 tables just on 50 data sources, not more than that. We have another 150 to go. We profiled that data. We made that data searchable and cataloged. And then right now in 8 weeks, we are ready to start working on the business use cases. All that is readily available on the plate. And this is, again, in just a matter of 8 weeks, and 9th week, we are working on their business use case. And as an analytical profession who has worked for 22 years, I'm immensely proud of this, because if any other company has to endeavor, I'm not kidding, it's not 8-week effort, this is 8 months effort. The amount of things they need to work on, build the pipelines, figure out the data, look at the data sources, manage all the operational details of the data sources. So it gets really painful in terms of how we go about doing this. Next slide, just talking about Modak. So this is some of the things which people are talking about. I know Prashant mentioned Doug Leaney. So this is what he talks about Modak, right? So how do you like scour the entire environment using data spiders, and then locate all the data where it exists, and then identify the information asset. And we don't even do that. We bring that up, we profile them, make everything ready for you to go. And then Mark, he's the CDO of GSK where we work, and we delivered our the first project. So this is what is about Modak. I think I'm well in time, so I have a lot of time to take some questions. I'll just go to this slide, and if you have anything else, I will happy to share. Thank you, Prashant.
Yeah, thanks, Milind. Pawana, do you want to unshare, or is it Milind? Milind, I think you have to. Oh, yeah. Okay. Thank you, Milind. Thank you very much for wonderful presentations. I see a couple of questions are already in the chat. I see one from Abhishek. Abhishek, do you want to unmute yourself, or I can unmute? Yeah. And do you want to ask? You are unmuted, Abhishek.
Yeah. Thanks, Milind, for the nice presentation. And I completely resonate what you said. And it can be tied back to what I learned from Prashant during my classes at IE as well. So thanks for that. So my question is very specific around data quality governance and master data journey. So what you said and the way the crawler works and the ML has been implemented, does it help the organization in their journey to streamline the governance, data quality, and master data management as well?
Great question. So let me answer that very succinctly. So I know when we say master data, we talk about MDM and master data management and all those things. What we can definitely tell is it does help with your data quality and understanding your data quality and our next iteration on this is actually creating a data quality dashboard. Right now we do it at a field level, but we want to go up and do it at a complete dashboard level of like what that data quality looks like in that organization. So that's definitely part of what we do. Governance, what I want to tell you is that governance is a very, very large subtopic by itself. And we as a Modak don't deal with data governance processes, but what we definitely deal with is helping that data governance processes. So what we do is, example, where is my sensitive data? So we can tag that and tell you that these sensitive data lies in all these data stores. Or we can go and tag and tell you that here are the accesses which are available for different data, and who gets to access what. That's also built in our Nabu toolkit and access management and what you call, as far as governance is concerned, we tag the data, we identify the data and tell you what it is. But we don't really grow into the processes like typical data governance processes and workflows in managing that data governance. I still leave it up to tools like Colibra. What we will do is we will feed that information into Colibra and also pick information back from Colibra. I hope I answered your question.
Definitely, this is what I was looking for. Thanks a lot, because I was understanding a little bit of Colibra aspects out there, how it exactly gets coupled into it and how exactly it works together. So thanks for that, Milind.
Thank you.
So Milind, this is Prashant. So you mentioned like almost like all those scary numbers, about 80% of the time is spent on data preparation and all. So what do you think would be the fundamental, okay, we see the symptoms that a lot of time is gone, is wasted on this work, but why do we have this problem in the first place? So
yeah, so because of the way organizations implement their operational systems, right? So there is a myriad of operational systems which nobody has control over, and every department, and it's a very hard problem to solve, because every department will go and say, okay, I want to build this process on Salesforce, or I want to build this process on ServiceNow, or they have their own legacy systems which they have built these operational processes, and they have not build those rules in those operational processes to manage their master data or do these kind of qualities. What I would say is that is an unsolvable problem. People have done this MDM journey. People have tried to solve that problem. People have tried to create a single version of truth. And in my 22 years of experience, now 23 years of experience, I have not seen that successfully implemented anywhere, right? So I think it's just a nature of the beast, that the data is so bad or in different formats, or how the operational systems or the engagements are spanned, especially for large enterprises. The only solution I see is we need to figure out automation. We have far too long, industry has focused on using machine learning on the gaining the insights and all those things. How about we apply machine learning on the major data preparation itself? How do I pick that machine learning or the data science and start figuring out how do I organize my data better?
Okay, that's a great point. Yeah.
I have.
Yeah, so this is Santosh here. Am I audible?
Yeah, Santosh, you're good. Yeah.
Excellent work, Milind, because I've been in the field for several years, similar to you, and I know the kind of challenges that enterprises have, right? The data management is the biggest challenge out there, right? And I think all of us have been in business. Thanks to, technology has evolved, but these challenges have always existed in large enterprises, right? And the way they have grown. So, my question is, you try to, this is excellent that, you're trying to automate the data prep, right? So are you selling these tools independently, or as IP products? The cataloging to me is excellent, because that is one of the things that I've been looking at, right? How do we actually catalog? You have a data lake, great, you have a data lake, but if you can't catalog it, it's of no use, for me, right?
Yes.
So
absolutely.
Are you using it as part to, deliver your services, or is there something is an IP, like a product, you're also selling this IP? Is it,
so all the, yeah, so we only, unfortunately for us, we're a very boutique firm. So we only have 4 accounts, and all 4 accounts are like top, 3 of them are top 3 pharma companies of the world. And one of them is top 5 healthcare insurance company of the world. But at all the places we have deployed our product called Nabu. So what all the acceleration I'm talking about, there is this product which we have worked for 4 years and accumulated all this IP and put that in a product. And this is what we deploy. So the latest client which we are also executing is a truly like a Nabu 2.0. And earlier it was Nabu 1.0, and with 2.0 we made more changes, and we have that product, and it's a licensed product. So we come in and we implement it. Where we love to see ourselves is actually we want to deliver the value of the client in services in the automation of that, however we can automate the data prep piece. I don't say that we are completely automating the data prep piece. Once that happens, if you want our services, we come and help you with the data transformation, because that's where the value of the business is. So we have the product, we come and implement it, and then as a services provider, we come and also help you with the data preparation, business use case transformation. The reason is, if you have a single provider who does all these things, our neck is on the line. A lot of these organizations which we work with, always our neck is on the line. It's not like we are selling a software product and moving away. We are actually on the line to deliver that promise which we made to them.
Yeah, excellent. I mean, yeah, I just was wanting to know that, yeah, is it a licensed product? And I think the answer is yes, because
yes, it is a licensed
not a
product.
plug and play. Yeah.
And luckily for us, it has been recognized even with 4 clients. It has been recognized as very innovative by Gartner in 2019 and 2020 as well. So it's part of their data market guide for data preparation. Nabu, N-A-B-U, and Nabu means God of wisdom in Assyrian culture.
Yeah. I mean, automation is not possible in large enterprises from a data integration perspective. Only if you've been there, you know how complex it is. There are hundreds and thousands of systems, and it is yeah, somebody is smoking if they think they can automate. But no, I mean, for example,
no, I completely agree with you. Means as a fellow thing, I am also not coming. Whenever some people say it's automation of data preparation, it's not. What we are saying is we'll accelerate that journey, right? We are saying that we'll automate as much as we can, and then using that metadata, we also help you do a better curation job. So again, whenever I get scared when people say, yeah, this is automation of data preparation. No, that's not what we are trying to sell.
Yeah, I think, but the newer generation, for example, this neo-gen banks, probably there you could claim that this could do automation, because the landscape, the system landscape itself is so simplified, right? I mean, everybody is just on the cloud, fewer systems. Yes, there you could achieve, automation, say up to 80-90%. But in traditional large enterprises, the problem you're solving is very complex problem with this pharma companies. I mean,
absolutely. And pharmas are the worst. Means I spend almost all my life in banking and insurance companies, and now when I come to pharmas, I am extremely humbled. I'm extremely humbled by what they do and the challenges they face and how they are even able to discover a single drug. And we know that for last 6 months, I think everybody's praying for a COVID vaccine, and you know how hard it is. It's not like AI running and within 5 days I have a solution for it. And I would love to make this point. Are we not truly humbled, and all the hype which is going on, AI and other things trying to solve drug discovery, and how many articles have you seen that AI is going to fasten the drug discovery? And it was the point right now for AI to really prove that it can do it. But I am truly humbled, and it's a good thing that we are humbled yet, that is not possible. Maybe another 10 years of applying this science there, we might be at a stage where within a month we are ready with some vaccine or some drug, or I don't know, I'm just hoping.
Okay. I think your largest market is also financial services, right? Because, I mean, I've spent a lot of time, and it looks like you spent insurance and financial services company. The data integration problem is they spend hundreds and hundreds of millions of dollars on that. And if I think some solution like this, they could be of big benefit. Yeah.
Yes.
Okay, good. So we are done for the time. Thank you once again, Milind. Before we depart, one thing, Pawana, you want to say something?
Yeah, can we all have a group picture? Like if you can on your web cameras,
Yeah,
you can
so I
have a
mean,
group
it's
picture.
okay. Yeah, so if you don't want to show your faces, you can keep
Yeah,
your
it's okay.
camera
Yeah.
off.
So are we ready? Okay. Yeah. Thank you.
Okay. So, Milind, once again, thank you very much. Milind, if you can send a kind of a summary or a key takeaway from your presentation to me and Pavna, we'll just summarize it and share it in LinkedIn probably tomorrow. I know it's late for you, but at least some kind of 75 words or so. So with bullet points, we will share it in LinkedIn.
Thanks a lot, Prashant, and for hosting me. Really appreciate. Nice meeting everyone. Thank you. Thanks for your time.
Thank you, Milind.
Thanks,
Great
Milind.
presentation.
Thanks.
Thank you. Thank you.